Hello, and welcome to IBM watsonx.data integration. In today's financial services landscape, timing isn't just important, it's everything. Markets move in milliseconds, and customer expectations evolve in real time. Risk can emerge and escalate in the blink of an eye. In this environment, relying on yesterday's data, or even data that's minutes old, is no longer enough. This is where real-time data streaming and data replication become critical data integration patterns. In this scenario, our marketing department wants to run a real-time promotion to target active credit card users that have high annual salaries. The streaming transaction data needs to be ingested, enriched, filtered, and then moved to a cloud database before being replicated to another location. Let's see how IBM watsonx.data integration can meet this challenge. From the home page, let's open our working project and then create a new asset. We need to stream real-time data, so we'll select the real-time streaming data flow tile. After entering a name and description and selecting our environment, let's create the project. The real-time streaming canvas provides a drag-and-drop interface with numerous different types of connections to data sources. Our credit card transaction data is moving through Kafka, so we'll need to begin our data flow with a Kafka multi-topic consumer source. Let's open the configuration pane. Here, we can enter the topic name we need in the list. We'll also select JSON for the data type. A quick data preview shows that we've successfully ingested our credit card data into the flow. We can exit the preview now. Next, we'll need to add a few processors to transform our data. First, we need to look up demographic information for the cardholders that's stored on a SQL server, so we can use a JDBC lookup processor to inject additional data into the flow. Our thoughtful system administrator has already made a pre-built shared connection to this database, so we can select it instead of typing it manually. A simple query will pull in the columns we need. Let's run another preview and make sure we're getting this new data. Sure enough, we can see it's been added to the records. This new information will help us identify the high earners that our marketing department requires. High earners in this case are active card users who earn more than $200,000 per year. We need a processor that splits the data in the flow according to the marketing department's criteria. The Stream Selector processor does just that, acting as a customizable filter. Adding a value to the Stream Selector creates a new data stream. Using the expression language, we can write an expression to split the data according to the criteria that marketing needs. After saving, we can see two output streams now. The marketing department will get the data they need, but they don't need to see each high earner's actual salary. For privacy reasons, we can mask this information. Let's use the field masker processor for this. After connecting the data stream, we can quickly select the field or fields we want to mask from the pre-populated schema. The remaining data is not needed by the marketing department, so we can simply discard it. The trash target does just that, so let's add one for the second stream. After adding and connecting it, though, you can see that our flow design got rearranged. Fortunately, the Arrange button puts our stages back in order. Now let's add the last stage in our data flow, an IBM DB2 target. We'll connect the field masker to the target, and then configure it. Once again, our amazing system admin has pre-built a shared connection for this database too. We just need to add the schema and table name. This stage also has a feature that can automatically create new tables if they don't already exist, so let's select it and then save. Time for one final data preview. Looks good. The yearly income value is successfully hidden. Let's exit the preview and run this flow now. Running this flow will start a job that transfers the data from Kafka, enriches it with SQL data, and saves the data, with the salary masked, to marketing's DB2 database. While the job is running, let's look at some statistics about the job. We can see that data is moving, but we can't see the data, so let's log into the DB2 database on IBM Cloud and verify that it's there. We can find the data quickly by clicking the Data View button, then the Tables tab at the top. We'll select our financial data schema, then the Small Users 3 table. The table definition displays to the right, but we want to view the actual data. Looks like the data successfully landed in the table with the masked salary value. Another group in the marketing department has asked for a copy of the data sent to their Kafka stream so they can use it as a data service to power multiple applications. Let's return to Data Integration and create a new flow to replicate the data and meet their needs. After entering a name and a brief description, let's continue on and select our source. The target data from the first flow that we want to replicate is saved in a DB2 database, so let's select that connection. We want to select the DB2 PureScale environment with the member number of 0. Now let's select the data. Recall that our financial data schema contains the small users 3 table, which is where the data is stored. With the right data selected, let's pick the target. Let's select the pre-built Kafka connection that our administrator made for us. We'll need to add in the right Kafka topic, and then we can review our progress. Everything looks good, so let's create this data flow and then run it. The pop-up shows the flow started successfully, so we should be seeing event log entries at any moment. The metrics graph updates in real time as well and shows us how much data is being replicated to the target. And that's it! In a matter of minutes, we were able to pull streaming credit card transaction data together with demographic data from a database, and then enrich and filter it before landing it in a cloud database. Finally, we replicated a table from the cloud database to another Kafka stream to power additional use cases. The future of financial services is real-time, data-driven, and always on. With IBM watsonx.data integration, you're not just keeping up. You're staying ahead. Thanks for watching.